Welcome to the Energy Central Power Perspectives podcast. This is the show that brings leading minds from the energy industry to discuss the challenges and trends that are transforming and modernizing our energy system. And new for 2024, our listeners can join in on the conversation by going to the Energy Central podcast post, finding the link labeled SpeakPipe, and we may select your question and recorded voice to be on a future episode. And a quick thank you to West Monroe, our sponsor of today's show. Now, let's talk energy. I'm Jason Price, Energy Central podcast host and director with West Monroe, calling in from New York City. And with me, as always, from Orlando, Florida, is Energy Central producer and community manager Matt Chester. Matt, we've got an exciting program for our listeners today. We're back again with some leading minds from the Idaho National Laboratory, and they are here to share about a recent study on the impact of the Inflation Reduction Act on nuclear power plant uprate and hydrogen cogeneration. I know we'll hear from our guests about the details, but can you kick off the conversation with a 50,000-foot summary of this study?
Sure, Jason. So the study that you're referring to was from INL's Light Water Reactor Sustainability Program, and it came out last fall, titled Assessing the Impact of the Inflation Reduction Act on Nuclear Power Uprate and Hydrogen Cogeneration. And the study basically focused on how the IRA has incentivized investment in new carbon-free power generation and sustainable operation of existing assets through tax credits, basically emphasizing the potential for utilities to maximize carbon-free electricity generation through the uprating of their nuclear assets. So the INL team, they estimated the significant untapped power potential. They looked into the market opportunities for these uprates and the hydrogen cogeneration, and they helped advance a conversation on this strategy to advance national decarbonization goals amid, a rapidly changing energy landscape. So it's definitely something we're eager to hear more of the nitty-gritty about.
Absolutely. Thanks for that preview, Matt. And since we're jam-packed with three different guests today, we want to get right to bringing them in without wasting time. So let's introduce them. First, we have Svetlana Lawrence, INL's Risk-Informed Systems Analysis Pathway Lead. Welcome to the episode, Lana.
Thank you for having us. We're happy to be here.
And joining Lana is INL's Hydrogen Infrastructure and Analysis Manager, Fred Joseck. Thanks for joining today's conversation, Fred.
Yes, thank you, Jason. Thanks for the opportunity to discuss the production of near-zero carbon hydrogen from nuclear power.
And last but not least is the team's energy economist, Levi Larsen. Welcome to the podcast, Levi.
Thank you. I'm excited about our conversation today.
As are we. So let's get started. Let's start at the beginning by getting the background story behind the Light Water Reactor Sustainability Study of the IRA and its impact on nuclear power plant uprating. So Lana, let's kick it off with you. Can you please give us the elevator pitch? Let's start with what is uprating? What was the purpose of the study? What were the basic findings? And how should the energy world be interpreting and using those results?
Yeah, the uprating is basically increasing the power output from the existing nuclear power plant. And these power uprates is not really a new concept by itself, because we as industry, nuclear fleet here in the United States, we have done over 170 power uprates. Different scale, from small, about 1%, all the way up to 20% of power increase. But recently, I would say last about 10 years, there was no market opportunity to uprate power. Because of our market conditions, especially in deregulated market conditions, nuclear energy struggled to be competitive with other energy sources like renewables and natural gas because of low price of natural gas. So we, as nuclear industry, struggled to sell existing power. So there was no real reason to increase power output if we're already struggling. But the IRA incentive were seen to be significant enough after IRA was passed in 2022, and industry wanted to understand, okay, is it just our perception, or is the impact significant enough that we can go ahead and justify economically that we can produce more energy and be able to sell it and be profitable. And that request from the industry was very urgent, very much needed, and Department of Energy approved the feasibility study that LWRS program performed. And kind of jumping back, we found out that those IRA incentives are indeed significant enough, and there is enough benefit, economic benefit and justification for the industry to go ahead with the power uprates, and we will discuss it later.
Yeah, so all right, so given the IRA, Fred, I want to turn the next question over to you. We've been seeing some excitement surrounding hydrogen energy in the past, but some stakeholders may feel like it's been a lot of hype, but with minimal tangible results to date. What new opportunities are we seeing now in light of the IRA and integrating hydrogen energy as part of the entire sustainable energy system?
Sure, Jason, thank you for the question. I'm going to address your question in two parts. First, I want to emphasize that hydrogen offers a tremendous opportunity to make a sizable impact towards decarbonizing U.S. industrial and energy sectors. Especially hydrogen produced from electrolysis with nuclear power is a pathway that can significantly decarbonize not only the energy sector, but also the industrial sector that is hard to electrify. Nuclear-based hydrogen is near zero carbon and is especially important because it can be continuously produced in large quantities on a 24/7 sustainable basis. The second part of your question was related to IRA incentives for hydrogen and how they could impact nuclear power. Department of Treasury and IRS issued the proposed draft rule associated with the IRA credits for hydrogen, which can be a topic for a standalone podcast as a suggestion. But the IRA draft rule especially allows an owner-producer clean hydrogen credits. To claim these credits, the produced hydrogen must meet criteria and constraints as defined within the IRA for clean hydrogen. An acceptable pathway for these credits is producing hydrogen from electrolysis with nuclear power produced, and this pathway can be very beneficial considering a nuclear power uprate since it adds additional electrical power that can be used for producing clean hydrogen.
Yeah, that's really interesting. So let's go to Levi. I mean, Levi, you're the economist on the team, and no team is complete without their economist. So our listeners are tuning in, are undoubtedly working on, distributed energy resources, clean energy sources, and other sorts of innovative approaches. So how do the findings of the study impact the calculations that can and should be doing? And how significant are these findings and the opportunities that lay ahead?
Yeah, so a key part of the study was to show the impact of the tax credits created by the Inflation Reduction Act. More specifically, that said credits created a legitimate business case for both power uprates and hydrogen cogeneration. Now, obviously, subsidies always make the financials look better, but in the case of uprates with or without hydrogen cogeneration, the large capital costs must be offset by larger future revenues. We show that it is very possible for those tax credits to do just that. This is a significant finding because the financial risks associated with capital-intensive projects can often be too much to warrant action by investors. So by showing that the financial risk is offset by these tax credits, it makes uprating a very real option for reactor operators across the country. And it presents a great business justification for hydrogen cogeneration.
Very good. So when we're talking about uprating, there seems to be a lot of excitement for what lies ahead, but surely it comes with additional challenges. Lana, over to you. Can you share with us some of the key bottlenecks or pain points that you see arising and how you and your team are looking to help stakeholders address them?
Yes, this is a great question, Jason. And I would start with the note that a large project always comes with challenges. And in this case, in the power uprate case, there are several challenges. So to emphasize, we need to go big. We need to go after large power uprates to make them worthwhile. So we need to make them as large as technically possible, as large as our power equipment, as the power plant can support them, to make it worthwhile either for additional clean energy or for hydrogen generation. And this means that large uprate means that many systems at the plant will have to be either refurbished or even replaced. And that will be a very, very large and complex project, complex industrial project with so many systems being replaced. Then the next challenge is, as you know, safety is a key for operation of our nuclear power plants. And after all these plant modifications and increased power output, we have to make sure that the plant remains safe. Our public and environment remain safe. We are not increasing possibilities of accidents because of those modifications. So these are the key challenges. Then there are economic challenges. We need to make sure that the projects are completed on time, on budget, that we have enough resources, the supply chain is ready. So there are plenty of challenges, but let me be clear, we have done this before. We have done more than 170 power uprates. We have done large projects in this country. We can do it again, but we really need to understand those challenges. Again, great question. And we're working very closely with several industry organizations and utilities and vendors to identify those challenges, those technical gaps, and pencil down the potential solutions to come up with a roadmap to go with the larger power uprates and go with the near-term power uprates, because we don't have enough time. We don't have much time to wait because IRA incentives are limited, time limited. So we really have to come up with the solutions quickly.
Yeah, understood. All right. So hydrogen is an exciting area because it crosses over to the other industries in all sorts of intriguing ways. Fred, this one's for you. Given the close work you do on hydrogen as a resource, can you tell us how the tax credits and opportunities for power producers to create hydrogen may do for other industries, and how those energy companies should be looking to build out those potentially new avenues for them?
Yes, Jason, that's a great question. And again, break the question up into two parts. First, I'll address the tax credit opportunities for hydrogen production, then the opportunities created for industry. Hydrogen is an energy carrier that has been utilized for a long time in the U.S. and throughout the world. In the U.S. alone, we make about 10 million metric tons a year of hydrogen that is used for refining, chemical, and other industries. The tax credits can be utilized by utilities and hydrogen producers, and those tax credits are 45B, 45U, 45Y, and 48E. I know it's a lot of numbers, but I'll talk about those in a minute. The direct tax credit for clean hydrogen is 45B. The value of this tax credit is based on carbon emissions for the production pathway. In particular, in our conversation today, hydrogen produced from electrolysis with nuclear power is one of the lowest carbon pathways at being less than 0.45 kilograms of CO2 per kilogram of hydrogen, and gets, based on the criteria of the IRA, it gets the maximum credits of $3 a kilogram of hydrogen. Nuclear power can be integrated with electrolysis to also utilize 45U, which is the tax credit for clean nuclear power from an existing nuclear power plant. And also there are the tax credits of 45Y and 48E for investment in new nuclear power uprate or new nuclear power plants, which is applicable for, as we're talking about, for power uprate, and which was discussed in the study. 45Y is a clean power production tax credit that is part of this for new production or new capacity. And 48E is an investment tax credit, which covers the construction costs and capital costs for investment in either power uprate, new nuclear power plants. The second part, in particular, about how companies can take it and utilities can take advantage of the hydrogen tax credit and the others. The clean hydrogen tax credit will reduce the cost from a clean pathway and attempt to make clean hydrogen cost competitive with fossil fuel-based hydrogen. Currently, over 90% of the hydrogen produced in the U.S. is from steam methane of natural gas, and it costs about $1 to $1.50 a kilogram. For industries that currently use hydrogen and want to reduce their carbon footprint, the reduced cost of clean hydrogen will be competitive and offers an opportunity for some of their hydrogen supply and offsets the barriers to entry for these clean hydrogen supplies. Also, these tax credits can be applied for nuclear power plant uprates that for industries are considering the use of clean hydrogen for fuel substitution and other applications and clean energy such as heat and power. These industries include chip manufacturers, steel, pulp and paper. So this kind of gives you an idea of how industry and nuclear power would be able to work together to be able to acquire these tax credits.
That's great, Fred. I really appreciate it. And I just want to point out for our listeners, there's a lot of important information that Fred has shared. You can get the entire transcript off of the Energy Central Power Perspectives website. So it's definitely refer back to it for some of the important data that Fred had just shared. So let's get an economist perspective in this. So Levi, over to you. How do you see the evolving landscape of hydrogen demand influencing the decision-making process for utilities? And what economic factors should utilities consider when determining the feasibility and profitability of transitioning to hydrogen cogeneration?
So I think the important thing to key in on here is really the future of clean hydrogen demand. So in a world where you have net zero targets that continue to gain momentum, you see a variety of initiatives pushing for more and more adoption of clean hydrogen. And sometimes this is for industries that don't even use hydrogen in the first place. The Inflation Reduction Act was a good example of this. The Department of Energy's 111 targets, which were targets to reduce the cost of clean hydrogen, was another. Then the announcement of hydrogen hubs across the entire U.S. served as a signal that clean hydrogen should be seriously considered for those wishing to decarbonize their processes. It appears that a variety of industries that don't currently leverage hydrogen may turn to clean hydrogen to help decarbonize their processes, which in turn will lead to increasing demand in the future. Utilities that are looking at capitalizing on this really need to understand if players in their regions could actually use clean hydrogen and the prices that those industries are willing to pay. Argonne National Laboratory has done some fantastic research on the different threshold prices that different industries might accept for clean hydrogen. And it's possible that some will require very low hydrogen prices, which in turn will eat away at the profitability of these cogeneration projects. So utilities considering this really need to key in on what price they think they can get in the immediate market and also how much a given application might need. I'm a good economist here, and I've got to throw in supply and demand. So there really needs to be a supply and demand matchup here for both the utilities and those purchasing the hydrogen for this to work out.
I recall an intriguing part of the study was not just the opportunities today for uprating nuclear and integrating hydrogen, but also the ways that digital innovation like AI and machine learning are being integrated. Lana, I know this is your area. Share some of what you're seeing. What's exciting that's coming down the road?
Yeah, I share your excitement here, Jason. That's a great point. I mentioned before that the large power uprates will necessitate this large plant modification. So let's imagine if you're a utility and you haven't yet decided if you want to extend your plant operation beyond for another 20 years, so let's say beyond 60 years. So now you're saying, okay, I'm doing all these plant modifications. So it only makes sense to extend the plant lifetime for additional 20 years, given that you upgraded most of your major systems. And these large modifications, let's say you're already guiding, let's say 25% of your plant for whatever amount, right? So large systems are being upgraded. So that is a great opportunity to modernize those systems or supporting systems. So not to make a like-to-like replacement, But to make systems better, to make them more efficient, to implement those digital technology for monitoring and support of operation, to make the plant more efficient. And that would not only increase the power output, so the power upgrade process and those plant modifications not only increase the power output itself, but it will also allow us to reduce operating and maintenance costs. And these are the largest contributors to the cost of nuclear energy. And another point I wanted to make here, the large power uprates will require resources. It's workforce, equipment, because we're nuclear, it will be nuclear-grade components, it will be nuclear-grade materials. And the supply chain right now in the nuclear sector is recognized to be one of the largest challenges, not for necessarily existing reactors, but for the expected at-scale deployment of new reactors. So the existing plants in their large power uprates projects would kind of organically energize the commercial sector to support these nuclear projects, and it will get us kind of prepared and propelled into this expected large wave of new nuclear plants. So again, at the face value, it's a great opportunity to just gain near-term additional clean energy or clean hydrogen. But this opportunity is much, much larger than just that.
Yeah, that's really exciting. How about over to Fred and Levi? Can you share with us some other tech use cases you may have seen?
Yeah, Jason, this is Fred. I'll go first. Yeah, the hype and interest for artificial intelligence and machine learning is very relevant and very applicable to the case that we're talking about of producing hydrogen from nuclear power. As you know, in the base case, nuclear power plants are base load and provide reliable 24/7 electrical supply to the grid and interface with the grid operation and grid operators. So by integrating hydrogen production with nuclear power introduces a new opportunity to include now AI and machine learning. The dynamics of trying to supply electricity to the grid and then to hydrogen supply and storage will be a control opportunity. When I say control, they're trying to make sure they provide power to the grid, power to reliable, continuous operation of hydrogen supply. And then there's also the opportunity to provide clean heat and steam from nuclear power plants that can be used by industry. So this adds another variable. So these opportunities now present a very formidable application of artificial intelligence for future opportunities. Along these lines, I'll take a moment for an infomercial, if I may, that the nuclear industry is very advantageous in ability to supply continuous large-scale clean energy supply. We talked about hydrogen and clean heat. Well, there are great opportunities for industry which are working in a world-scale economy and have to supply clean products. And there's a lot of pressure on the world markets for companies to provide clean products. And by having hydrogen to decarbonize their industry helps these companies achieve their strategies for net zero carbon by 2050. And as a result, the clean energy supply from nuclear power plants can be critical for future world economy.
Yeah, I would agree. Levi, you want to take it home?
Yeah. So this isn't exactly technology driven, but something that stuck out to me was the idea that hydrogen cogeneration creates a de-risking effect for utilities by diversifying their revenue streams. So for anybody who has looked into investing personally, you know that diversity is key to prevent downside risk. And the same holds true for businesses. When you only have one product or one revenue stream, there is an inherent risk associated with that. Cogeneration of hydrogen or any process benefits utilities by creating a hedge that offsets the risk of only having one product and one revenue stream. So I actually see this as a very positive thing that could further strengthen the financial position of nuclear utilities.
That's really interesting. This has really been an interesting conversation, and we want to give you the final word to all three of you. But we're now at the point of the show what we call the lightning round, which gives us an opportunity to learn a little bit more about you, the person, rather than you, the professional. So we have a set of questions. It's 5 in total. We ask you to keep your response to one word or phrase. Since there's 3 of you, why don't we go in order of Fred, Levi, and then Lana? So, are you all ready?
I'm
Sure.
ready. Let's do this.
Okay. All right. So Fred, Levi, and then Lana. Dream vacation spot.
See me in Rhodes, Greece.
The Isle of Skye in Scotland.
Yeah, and I'll pick national parks in Alaska with a preference with the summer, not winter time.
Okay. Best gift you've ever been given.
The best gifts that I've been given are my wife, my children, and my grandchildren.
Yes, I feel like after Fred says that, if I say anything other than my family, I kind of look like a terrible person. But what I was going to say was I got a special poster of a band that I really enjoy, which was Daft Punk.
Yeah, I'm with Levi. Now I have to say, okay, that's my family. I didn't forget about them. But other than that, it was actually a bicycle. And I was 32 when I got that bicycle, because after that I started riding it, and I'm still riding it, very much enjoying it.
Love it. All right. Do you have any hidden talents?
I'm good with my hands, very practical, and I can build and fix things pretty good. I can help my friends and children through a lot of their household problems. So, yeah.
My talent is that I can go for a shockingly long period of time without very much sleep.
I need to remember it, Levi, for next big project and milestone.
No.
Thank you.
You didn't hear that, Lana.
Yep. Mine is actually, it turned out to be pretty good in photography, nature photography. Actually moved to Idaho about 4 years ago. It's very beautiful here, and I discovered I have a talent to take nice pictures of bears and moose and mountains.
I'm really liking these responses. All right, back to you, Fred. What motivates you the most?
Really motivated about the ability to take strategies and being able to see them to being applied and being brought to market. So, such as the nuclear-based hydrogen and hydrogen in general for decarbonization.
I would say for me, relationships motivate me a lot. It's really important for me to find ways to connect with the people that I spend time with, regardless of if it's in work or not. So those relationships really do motivate me.
Yeah, for me, I would say how my time or efforts and work, it contributes to something positive, relevant to our conversation, how our work here keeps nuclear alive and well and progresses it forward. So that is a huge motivation for me to do what I do.
All right. And then the last question, which is going to be interesting, hearing from 3 researchers from INL. So the question is, you have an opportunity to influence a future lightning round. What is the one question, energy focused or otherwise, you'd like to pose to one of our future podcast guests in this lightning round? So Fred, over to you.
I would say we've talked a lot about the tax credits and their implications. I would say a podcast of the details, how they could be applied, some of the implications would be a good follow-up to this.
Levi?
As a researcher from the leading nuclear laboratory of the Department of Energy, my question that I would like to see people answer is a hot dog a sandwich? We've debated this for some time, and I really appreciate the insights of your future guests on this.
Lana?
A good one. Good one, Levi. I would ask, what is the single most significant challenge to deployment of new nuclear reactors?
Fantastic. Wow, really impressive. And what a great experience hearing from all of you on this lightning round. So I did say you're going to get the final word. So you've got utility leaders and decision makers in our audience. What is the resounding message you hope you can impart to them today? The one takeaway, the hope that they'll keep listening and keep engaged in the conversation. Levi, why don't we start with you? What would it be?
Yeah, I think the biggest takeaway for me from this research was when I realized that nuclear has a very real opportunity to become a leader. Uprating and hydrogen cogeneration are ways that the nuclear industry can show just how vital it is to meeting decarbonization targets. I think that seizing the positive opportunities when they come is huge for the nuclear industry. And the IRA has created a very positive opportunity that should be capitalized on. Our research, along with the research of all the others that are leading in this space, has helped lay the groundwork to prove it's a profitable endeavor. Now, we need utility leaders and decision makers to help lead the charge that I think really could have a lasting impact on our industry.
Svetlana, how about you next?
Yes, the power uprate is a really unprecedented great opportunity for nuclear energy industry. But the last thought is we need to act fast. We really need to be dedicated, and we have to embrace collaboration to make it count.
Fred, you get the final word.
Yeah, Jason, thank you. And I want to build on what Levi and Lana discussed. And right now is the call to action. And you have a great opportunity now with the tax credits and with the industry interest for the nuclear power sector and industrial sectors to come together, be able to apply these tax credits, be able to utilize clean energy and hydrogen from the nuclear power plants. These are not going to be inexpensive opportunities, and to mitigate the cost is going to be looking at opportunities of whether joint venture, whether having mutual projects together, understanding each other's needs is an opportunity now to work together as we go forward and build for our future. So the utilities should be engaging in these projects for decarbonization, especially given the current situation on a world basis.
You're absolutely correct. We are at a historic junction, no doubt about it. And I know this topic will ring a lot in the Energy Central community, and we're eager to see the questions and comments that will come through from this episode. But until then, though, we just want to thank you for sharing your insight with us on today's episode of the podcast. And you can always reach our guests today through the Energy Central platform, where they welcome your questions and comments. And for any listeners who think they have any questions that we're not asking, we challenge you to share them with us. Listeners can head to the SpeakPipe link, where you can leave in the show notes questions and maybe even hear your voice on a future episode. We'll listen through them and hopefully hear from you soon. And also want to give a thanks to our podcast sponsors that made today's episode possible. Thanks to West Monroe. West Monroe is the leading partner for the nation's electric, gas, and water utilities, working together to drive grid modernization, clean energy, and workforce transformation. West Monroe's comprehensive services are designed to support utilities in advancing their digital transformation, building resilient operations, securing federal funding, and providing regulatory advisory support. With a multidisciplinary team of experts, West Monroe offers a holistic approach that addresses the challenges of the grid today and provides innovative solutions for a sustainable future. Once again, I'm your host, Jason Price. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com, and we'll see you next time at the Energy Central Power Perspectives Podcast.